Okay, so now let's look at the distance formula. This should be, you should have had this in Algebra 1, Algebra 2, Geometry. Okay, so this should be at least your fourth year on this. The distance formula. First, you need to go back and remember perfect squares, because this author is going to have you simplify. Okay, so remember, if we take 1 squared, 1 times 1, 2 squared would be 4, 3 squared would be 9. These are all your perfect squares. 4 squared would be 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, etc. Okay, those are all perfect squares. When you're simplifying the distance formula, you're working with simplifying and finding perfect squares. For example, they will say to simplify, and when you get your answers, you're going to simplify the square roots. Okay, for example, if I said the square root of 90, okay, they don't necessarily want you to just go to the calculator. What they want you to do is find the largest perfect square inside there. And I don't care if you do factor trees, or if you do, some of you did like the upside down cakes. Okay, I don't care how you do it, but you look for the largest perfect square inside there. Like if I did 3 and 30, and then 3 and 10, and 5 and 2. You break it down into primes, and then the ones that repeat, here's your largest perfect square. So you would break that up into 9 times 10. Okay, break it up into what's left. And then out of this, you can take out a 3 and leave the square root of 10 inside. I always like to circle what I'm going to take out. If I did the square root of 200, what's the largest perfect square inside there? Do you know? 200? 100, yeah, because if I break it up into 2 and 100, 100's a perfect square. So I can go 2 and 100, and then out of this I can take out a 10, and the square root of 2 is left inside. Okay. What about square root of 98? Largest perfect square inside there? You know it's even, so 2 and what? 2 and 49, and 49 is a perfect square. So out of that you can take out a 7. Oops, out of that you can take out a 7, and you'd have the square root of 2 left. Okay. If I did like square root of 125, I can split that up into 25 and 5, and square root of 25 is 5, and I'd leave the radical 5 left inside. Okay. One that you might not recognize is like 108, but again, you can break it up into factor trees, figure out the largest perfect square inside there is 36. And out of this you can take out a 6. Okay. Another one like 112. Square root of 112. Largest perfect square inside there is 16. And out of that you can take out a 4. So some of that goes back to review a little bit of your Algebra 2. Okay. But it's been a while since you've done square roots. The next thing the author goes back through is the Pythagorean theorem. For any right triangle. Okay? And this was true in geometry, but they might not have emphasized it much. If it's a right triangle with a 90-degree angle, and by the way, how many degrees in a triangle? 180. On the interior angles add up to 180. In trig, the right angle is always an uppercase C, a capital C. I'm going to label this one an uppercase A for that angle. That represents that angle. This angle is an uppercase B. Okay? the hypotenuse in trig is always a lowercase c. The side opposite, angle A, this side is a lowercase a. The side opposite, angle B, is a lowercase b. Okay? And then Pythagorean theorem is a squared plus b squared equals c squared. That is the main formula for a right triangle for figuring out the sides. A squared plus b squared equals c squared. Okay, then on the distance formula, you can also find the distance. You can find the distance between 2 points using the Pythagorean theorem. You can graph them, use the a squared plus b squared equals c squared, or you can use the distance formula. If they give you two ordered pairs, x sub 1, y sub 1, and an x sub 2, y sub 2, if they give you two ordered pairs, now depending on your author, sometimes they use d for distance, sometimes they'll use the 2 points, okay, but it's the square root of x sub 2 minus x sub 1. Notice in this formula, the sub 2 comes first. It's x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared. Okay? And that you just sub into the formula, and then you simplify. Simplify the square roots all the way down. Okay? Okay, and then the last thing the author goes through is the equation of a circle. And this goes all the way back to your Algebra 2. Equation of a circle. Remember, if it's at the center of your circle, it's x squared plus y squared equals r squared. And that one's at the center, 0, 0, and your radius is r. Okay, but if it's off center, it's x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. And that's where your center of your circle is at hk, and your radius is r. So like if they gave you x minus 3, quantity squared, plus y plus 2, quantity squared, equals, let's say 16. Okay, remember, you can graph that pretty easy. The center is at h. Notice the minus sign's already in the formula, so the h is 3, and the k would be negative 2. So you'd go 3 and down 2, plot your center. The easiest way to graph this, then, the radius would be 4. So go up 4, plot a point. Go out 4, plot a point. Go down 4, plot a point. And then go to the left 4. And there you've got your circle. Okay? Center's at HK. Okay, so on ours the center is at 3, negative 2. Okay, and the radius is 4. Okay? Okay, and that should be some review for that section.